Okay, so for the video this week, I wanted to do my own to help you out with the homework packet that I gave you. You've already had 2 videos on assigning oxidation numbers, as well as a little bit of work in class, but I wanted to get you started with this packet. So I've got a couple of examples in here as well as some directly from the packet. So you've already had 2 videos that looked at what this looks like, as well as a little bit of practice in class. But as a review, when you're assigning oxidation numbers, elements by themselves have an oxidation number of 0, meaning sodium, right? Sodium metal, that's an oxidation number of 0. Fluorine gas, see that little G there? That's an element by itself, even though there's 2 of them. Those elements have an oxidation number of 0. Also, ions. When ions are in solution, not when they're in a compound, when they're in a solution, they're going to have the charge that they would normally see. So say iron here with a 3+ charge, if you see that with a little AQ, the oxidation number for iron there is 3+. It's the charge that is literally present that you see. Fluorine is going to be a -1 always in any compound. It's always going to take a -1, whether it's an ionic or a molecular compound. Those group 1 and 2 metals or aluminum, if they're in a compound, you are normally going to give them the charge that they're going to take anyway. So sodium is always going to be a +1, and aluminum is always going to be a +3, and that's going to make those much easier. It's only the transition metals that you have to worry about that can sometimes be different things. Oxygen, as we said before, oxygen is normally -2, and we can typically assume and go ahead and assign that it's a -2. There are those rare exceptions, the peroxides, where oxygen can be a -1, or even when it's paired with fluorine, because fluorine up here is going to be the -1, and it'll actually make oxygen take on a positive charge, which is very, very strange. And that is just not normal, and you're not really going to see it. I'm not going to give it to you, and the AP test doesn't really use it. Hydrogen is going to be a +1, except with metals. And when it's with metals, it is going to have to take the minus charge because the metal is going to be the positive charge. And finally, if you have anything else, anything that is not an element by itself, an ion, fluorine, oxygen, hydrogen, or one of our basic metals, you're going to have to use algebra to figure it out. And this is what we went over in class. So for instance, this is magnesium nitrate. I've got magnesium, I have nitrogen, I have oxygen. So the first thing you have to figure out is there anything on this list that does not in this column? So we're going to have to figure out what to assign as X. And in this instance, magnesium, well, magnesium is a group 2 metal. I know that one. Oxygen, it's normally -2. I don't know that one. It's the nitrogen here that can be a little tricky. So I'm going to assign my nitrogen as my X because that's what I know. So again, this whole thing is going to equal 0. And left to right here, I know my magnesium is a 2. It's a +2 charge. Nitrogen is what I am assigning as X, but notice this 2 out here. So I'm going to say that is +2X because I don't know what that is. And then I've got plus, I have a total of 2 times 3, 4, 6 oxygens, and each of those oxygens has an oxidation number of -2. So my algebra here works out to 2 plus 2x -12. Combine that again. 2x -10. Bring that over. Solve. X equals +5 is the oxidation number for nitrogen there. So that should be easy. Okay. So when we have to assign across an entire reaction, you're just going to kind of follow along with those same set of rules. So for example, this, you should recognize that this is a combustion reaction. I've got methane and I've got oxygen making carbon dioxide and water. So kind of mentally go through the list and think of, what do I know here? All right, elements were first. Do I have any elements by themselves? Yes, I do. This is oxygen by itself. That has an oxidation number of 0. That's it. Ions. I have no charges anywhere, so I have no ions. I'm going to skip that rule. Group 1 or 2 metals or aluminum. I have no metals in this list, so I'm skipping that rule. Next, oxygen. I do. I have oxygen right here. This oxygen is going to be a -2. And this oxygen is going to be a -2. I know those. I'm going to go ahead and write them in. Hydrogen. I've got hydrogen right here. It's going to be a +1. And you'll notice I have 2 of those. 2 of those +1s. Well, that kind of cancels out that -2. That makes sense. So water works. I don't have to assign anything as X here. I can move on. I have this hydrogen over here. That's a +1. So really, it's the carbon in the methane and the carbon in the carbon dioxide that I don't know. Those I need to assign as X and figure out. So let's do the methane first. So 0 equals X, the thing I don't know, plus I have 4 hydrogens, each with a charge of +1. So 0 equals X plus 4. So X must equal a -4. So my oxidation number for carbon in the methane is a -4. It makes sense that it's a minus because the hydrogen is a positive. Now for the carbon dioxide, that is also 0 equals X, the thing I don't know, plus 2 oxygens, and each oxygen has an oxidation number of -2. So that would be X -4. In this instance, now X happens to be a +4. So my carbon in the carbon dioxide is a +4. Well, that should also make sense to you because the oxygen is a negative, and you're going to have a positive and negative in each one. So this is one reason why you can see that combustion reactions are a really big thing, because the oxidation number for carbon changing from a -4 to a +4, that's a really, really big deal. It's a big change, and these reactions do release a lot of energy. So another example. So in this example, we'll do the same thing. Go down your list. Do I have any elements by themselves? I do. Magnesium metal is a solid. That's an element by itself. I'll assign it as 0. Aluminum metal by itself, I will assign it as 0. Not the same as these guys over here, but these guys over here follow under that second rule. They are ions. I see the AQ symbol. I see the charge there. They're not in compounds. They're appearing this way. So their oxidation number, well, it is that charge. So magnesium is a +2 and aluminum is a +3. I didn't have to use that X trick. Everything is very, very obvious here, and you can see that aluminum had a change in oxidation state that way, and magnesium had a change in state that way. Okay, so the examples from the actual packet. So I picked one from the first set and one from the second set. So from the first set, we'll go and look at reaction B. So in reaction B, we will do the exact same thing. So first, scan through, do I have any elements by themselves? Here we go. Iodine. By itself, each of those atoms has an oxidation state of 0. Done. Next, do I have any elements existing as ions? Well, that's an ion, and that's an ion, but those are polyatomic ions. They're not individual ions. This is an individual ion here, this iodide ion. So I can assign this as its charge, as its oxidation number. So yes, there's a coefficient of 2, but that doesn't matter for the oxidation state. The oxidation number here is still a -1. So those are my 2 easy low-hanging fruits. Going through, do I have any group 1 or 2 metals or aluminum? No, I do not. So next comes oxygen. I have oxygen here at the oxidation state of -2, and I have oxygen here with the oxidation state of -2. So that means I don't know what sulfur is. in either of these situations. I'm going to sign it as X, and I've got two equations to solve. And do note that these do not equal 0 because they are polyatomic ions. So I've got a -2 equals my sulfur, which I don't know, but please be careful and look. There's two of them, so 2X, plus I have 8 oxygens, and each one of those has a -2 oxidation number. So -2 equals 2X minus 16. Pull that over onto the other side, and 2X equals let's see here, plus 16 over equals a positive 14. So that X equals a positive 7. So the oxidation number for sulfur in this equation is a positive 7. Positive, that makes sense. Oxygen is negative. I've got another sulfur here. It's clearly not going to be 7, but it should also be positive because it's paired with this negative oxygen. So again, starting off with a -2 equals, I can just use X this time because there's no subscript on the sulfur, plus 4 times the oxidation state of -2. And again, the 4 there is because there's 4 as the subscript. So we'll solve this. -2 equals X minus 8. Pull the 8 over with addition, and X is a positive 6. So sulfur's oxidation number in that sulfate polyatomic is a positive 6. So now I've assigned all of the oxidation states, and you can see that iodine changed oxidation numbers, -1 and 0, and that the sulfur changed oxidation numbers from a positive 7 to a positive 6. The oxygen stayed exactly the same, -2 and -2, and that's quite normal in a redox reaction. The second reaction is from the non-redox set, and this one will stick with the same process. Starting off, do I have any elements by themselves? No. No, I do not. Do I have any ions existing in solution? Yes, I do. I've got chlorine right here, so we'll assign chlorine as its charge that's shown. That's a -1. Then we can look through and assign anything else. I don't have any group 1 or 2 metals or aluminum, so let's look next on the list is oxygen. I have oxygen here. I will assign it an oxidation state of -2, and this oxygen here, -2. Next to my list is hydrogen. I have hydrogen here. I automatically assign it a positive 1, and I'm just going to stop and think here. I've got 3 of those positive 1s for a total of a positive 3, and I've got that -2, and this whole thing has a charge of a positive, so that makes sense to me. Next, another hydrogen, another +1, same thing, a +1 and a 2. I've got a total amount of a +2 over here, +2 and a -2. That makes sense that there's no charge. So I don't need to do any assigning of X. Everything makes sense. And then I've got this hydrogen. That's a +1. So in theory, I could assign this chlorine as an X, and that would be a very simple equation. I've got nothing here, so 0 equals a +1 plus X. So obviously X has to be a -1. And you know, you can write that equation out, but you should also be able to just look at this and know if this is a +1 and there's no charge here, that's a -1. So you don't have to write the algebra out if you can do it in your head. And that's honestly where I'd like you to be able to get to. For more complex polyatomic ions like this, this is helpful. But for simple things like this, do this in your head. Okay, so we look here, hydrogen +1, +1, +1, chlorine -1, -1, oxygen -2, -2. I don't have a situation like I do here. I don't have any changing oxidation numbers because this is not a redox reaction. So use these examples and start working your way through the packet now, and hopefully that this all makes a little bit more sense.